So now what I want to do is introduce you to the idea of exponential growth. And to motivate this idea, I have the following scenario on the screen. Suppose you have just received a job offer with two compensation packages. Which package would you choose? Compensation package A says you're going to get a starting salary of $50,000 per year with annual raises of $2,500 per year for the next 10 years. Option B gives you a starting salary of $1,000 per year with your salary doubling every year for the next 10 years. To help you see how these play out, I'm going to go into Excel. I'm going to open an Excel spreadsheet, and I'm just going to fill in the spreadsheet. The first column is going to be year, so year 0 is the first year you were hired, your initial salary, and then we just have the years go up by 1, and the 9 corresponds to your 10th year. So we're going to call this column option A, and we'll call this column option B. So let me shrink this down to remind you what the two options look like. Option A has a starting salary of $50,000. So that's $50,000 right there. And then your salary goes up $2,500 for each of the next 10 years. So in the start of the second year, or you're done with 1 year of work, your salary is going to be $52,500 because it went up $2,500. Each year after that, your salary also goes up $2,500. So if we take your salary in cell B3 and then add $2,500 to it, we get your salary in year 3. And then this little box down here allows you to copy and paste. So I'm just going to drag this down so you can see what your salaries are. I think the other thing that I'll do is format these cells so that it's currency. And we don't need the decimal places. So there's your salaries under option A. Now let's look at option B. You start with a salary of $1,000. Your salary doubles every year for the next 10 years. So think about this. That means at the beginning of your second year, you're going to be making $2,000. At the beginning of your third year, you're going to be making $4,000, again, because the salary doubles. And so we can write this as take 2 times your previous year's salary. So 2 times C4 will get your salary at the beginning of year 4, and so on. Copy this, and we get the following salaries. So you can see now at the start of your 10th year right here, under option A, you're making $72,500, and with option B, you're making over $500,000 a year. So I think it's pretty clear that picking option B is the better option. In fact, if you added your salaries all together, B2 to B11 for option A, cumulatively you've made $612,000, and in option B, if we add up all our salaries, we've cumulatively made over $1 million. So under that method of judging, option B is the better option as well. What I want to do is now look at what these equation graphs look like. Just visualize the data. So I'm going to highlight the data, click Insert, and then Scatter Charts. And I can make this a little bit bigger so it's easier to read. And I'm just going to call this linear versus exponential growth. Why I do that will become clear shortly. But the blue dots here, right here, that represents option A. And you can see that option A follows a linear pattern. The orange dots right here that I'm highlighting, that represents option B. what I want to do, and so you can, by the way, you can see here how with the exponential growth at the 10th year here, how much bigger your salary is with option B than it is with option A. So let us go back here, and I have those results shown. And the other thing that I've shown on the graphic here on the right is the trend line, if you will, from Excel. So let's try and find equations that describe each of these options. I'm going to start with option A. Option A, you can see that for each year you work, your salary goes up $2,500. So for option A, that's essentially the slope of the relationship. Your salary goes up $2,500 per every year. And your initial salary, or salary that you start with, that's the y-intercept, $50,000. So your salary as a function of X, the year you're working, is $2,500 times the year plus $50,000. That would be considered linear growth. Let's contrast that with option B. So I'm going to go slowly here. With option B, let's call the salary, again, let's give it a different name other than S. I'm just going to call it F as a function of X. Okay, so that's your F is the salary and X is the year. Your initial salary is $1,000. Your salary in year one is 2 times your initial salary, because your salary doubles every year. So again, that's 2 times $1,000. That's where the 2,000 bucks comes from in our spreadsheet right there. 2 times $1,000 can be written as your initial salary 1,000 times 2 to the first power. So if we color code this, I'm going to make the year in red each time so that you can see it. F of 1 is 2 to the first power. At the start of your third year, that you've worked 2 years, so now it's F of 2. That's going to be 2 times your salary in the first year. So that's 2 times your $2,000. And if you think about that for a sec, that's your initial salary times 2 to the second power. 2 times, or $1,000 times 4. And if we do your salary after your third year, F of 3, that's going to be 2 times your salary after the second year. So that's 2 times $4,000, and that's where your $8,000 salary comes from. So now we have $1,000 times 2 to the third power. So that gives me $1,000 times 2 to the x power. So again, if the argument is x, the exponent is x, just like it followed in this pattern. F of 1, 2 to the first power. F of 2, 2 to the second power. F of 3, 2 to the third power, so on and so forth. If we look carefully here, the $1,000 is your initial salary, and the x is the argument. 2, the base, is because of the fact that we are doubling your salary each year. And so that gives us the form of an exponential function. An exponential function is a function of the form f of x equals c times a to the x power. A is a positive real number, and A cannot equal 1. C cannot equal 0 is any real number. The domain of this function f is the set of all real numbers. A is the base, and A is called a growth factor. And finally, because f of 0 equals c times a to the 0 power equals c, we call c the initial value. So in our option B compensation model, the initial value is $1,000. That was your starting salary. And the growth factor is 2 because we were doubling your salary every year. Notice that when you have consecutive values of an exponential function, like for our salary model, 1,000 times 2 to the x plus 1 would be f of x plus 1. 1,000 times 2 to the x would be f of x. The thousands cancel, and then you have 2 to the x plus 1 over 2 to the x. When you have the same base and you're dividing, you subtract the exponents, and so you get 2. And so this theorem that is on the screen is saying that the ratio of consecutive outputs in an exponential function is going to be a constant A. Let me say that again. For 1 unit changes in the input, the ratio of the consecutive outputs is going to be a constant A. That's how you can tell whether or not you have exponential growth. And so way back here in our salary situation, you can see in option B, the ratio of consecutive outputs is always 2. 16,000 over 8,000, 2. 32,000 over 16,000, 2, so on and so forth. And so that's again, the method used to identify exponential functions.